Okay, here we are, problem 81, page 467. You have problem 82 as a sister. And this problem, if you had tuned into the previous video, we had done problem 79. Looks very similar to this problem, at least in the manner in which you approach it. Because both of those problems, 79 and 81, kind of share the same difficulty, very, very much the same difficulty. They've got two different trigonometric functions in play, and I need to kind of recast this equation in such a way that there's really only one. I want all sines or all cosines or all tangents. I'll take them with different exponents, but I want them all the same. And remember, what we did last time was to use the trigonometric identity. Tangent theta plus 1 is equal to secant squared theta, derivable from sine squared plus cosine squared equals 1, okay? Or derivable from your head if you can remember it. So let's go ahead and for this secant squared, put in tangent squared plus 1. And then when we do that, since this is the case, then secant squared becomes tangent squared theta plus 1. Secant squared becomes this plus tangent is equal to 0. And where I've got, excuse me, a quadratic function in the tangent. Now maybe it's one that you recognize. You could look at this as x squared plus x plus 1 is equal to 0 and run off and do it. But let's just do this. Rather than doing a substitution and turning this into x or u squared plus u plus 1, let's just go for it and say, hey, I'm going to solve this using the quadratic formula. I'm going to say it's opposite of b, plus or minus the square root of b squared minus 4 times a times c. And maybe you're all going, oops, all divided by 2a. And for those of you who are not saying oops, the reason the other people said that is because now I'm going to check it. Here's minus 4 times a times c. Yeah, sure enough, what I've got inside this square root bracket is 1 minus 4, or minus root 3. So this is minus 1 plus or minus the square root of minus 3 all over 2. Okay, and now, maybe you're scratching your head, maybe you've already gone on to the second problem. This says tangent theta is equal to an irrational number. Well, at this point in our lives, there is no theta whose tangent is equal to an irrational number, right? The range of the tangent is minus infinity to infinity. It's all the reals, but it doesn't have any imaginaries in it at this point. So at this point, we can just say, oops, no solution. Why are you wasting my time? Okay.